going to show a little demo here, a little virtual demo. This is this comes from the University of Colorado's website. They have a collection of very good sort of physics demonstration software. And I'll just write the URL on the board because you might want to actually play around with it yourself. It's free downloads. URL is phet.colorado.edu. And they have demos in all sorts of subjects, but I kind of like this one on lenses. Here's an object, okay, and what we're drawing are light rays. These are called the particular. We're drawing, first of all, we know that light from some source is propagating in all directions. Okay, so here's just a picture that shows many different light rays, but we're going to pick only rays that are going through the lens because those are the ones that we're interested in. So if I can show these ones as the light rays that go through the lens. Now I can't make this object appear infinitely far away, but you can kind of look at this. If I place these little X's here are the focal points, and again the idea is that you can either have light rays. Let me kill the lights because it's hard to see. Either you have light rays that are parallel to each other coming in from this direction are focused to a point, but in this particular case we have the opposite situation. This is the source. If the source is at the focal point, then any light rays that emerge will end up parallel to each other on the other side. Okay, so the focal point is parallel rays get focused to that point. When the rays are not parallel, or when the source isn't at the focal point, then the rays may converge at some different point, but where they converge is where an image actually forms. Okay, so this is our source, the thing I'm actually moving around. And if you look at the pencil tip, okay, we can think of one ray going through the edge here that gets bent down and it forms at this point. One ray that's going through the center, and ones through the center don't get refracted, and it meets that same point, and the one that goes through the edge here meets that point. Geometrically, what we often draw is what are called principal rays, and the principal rays, now this is a little weird because it looks like, well, this ray can't possibly get refracted because it's not going through the lens, and that's true, but we're kind of using it just as a geometric guide. Any ray that is parallel to the center axis, and let me bring it down here just to show, any light ray that's parallel to the center axis of the lens, when it goes through the lens, it'll get bent in such a way that it passes through the focal point. Okay, so one possible ray is one that's parallel to the axis. It ends up going through the focal point and continues on. Another possible ray is one that goes straight through the center of the lens. That one is not refracted at all, okay, and that continues on. And then another one goes through the focal point on this side. Any light ray that passes through the focal point on this side will be refracted in such a way that it ends up parallel to the center line on the other side. And so we can use those rays as a way to figure out where they're going to converge. Where they're going to converge is where an image is going to form. And that means if we actually placed a screen there, and I don't know if I can do it here. Let me do it. So here's a screen that I can move around. That means if I actually placed, so here the image is now changed to like a lamp. I place a screen right at the point where the image is, and I'm going to see a bright spot. Some light actually does reach that point, and I can project it onto a screen. Okay, so what we call a real image forms, and a real image is one that you can actually project onto a screen. What do you notice about the image compared to the original object? It's inverted. Okay, so why does that happen? Yeah. Okay. So this point down here is ending up below the axis, right? So we would think that any point below the axis would end up above. And you can show that by just drawing a second point. And let's imagine just the bottom, so it's kind of like having the top of the pencil has a little LED on it, maybe the bottom of the pencil has a little LED on it. We can track the light rays due to both of them. Same rules apply, though. I can draw a beam of light from the bottom of the pencil that goes parallel to the axis. That one will end up through the focal point on the other side. I can draw one through the center of the lens. That one ends up going through unrefracted. And I can draw one that goes through the focal point of this side, and that one ends up parallel to the axis. If I do that, we see that you really do have converging light rays from the bottom here that end up above the converging light rays from the top of the pencil. So the image is flipped, and this is what's true about any real image, at least a real image formed by a lens, is that the image is going to be inverted on the opposite side of the lens. Okay? Now, and that's going to be true for any image or any object that I have that is farther away than the focal length. And I can move them back and forth, and you can see how, depending on where this is, the image might actually be larger than the object, or the image might be smaller. But I will form a real image, or the light rays will converge on the other side. What if I move this closer than the focal length? It becomes a little bit trickier now to see. Let me go back to this version again. What's happening to the light rays now if the source is closer to the focal length? Are they converging? They're diverging, aren't they? They're diverging. What would we see if we looked through that lens? Magnification, right? Because what would happen? Let's put the pencil like this again. The image would get larger. So if I'm on this side, what it looks like to me is like these light rays are emerging not from this point, but they look like they're emerging from some point farther back. Okay, if I trace these light rays back along a straight line, they're going to converge, or at least to me they appear like they're converging from some different distance and a larger height off the axis. And so I can't form, now these light rays aren't really coming from this point. I can't form, if I put a screen there, I won't actually see anything projected onto a screen. But it looks to me like they are coming from that point. That's called not a real image, but anybody know? Virtual image. Yeah, this is called a virtual image. So a virtual image for a converging lens like this is, the virtual image is actually on the same side as the object, but it is larger, it's magnified, and it's up right side up. It's not inverted. So we see it's virtual because it appears to us to be coming from this point, but it's not really. Okay, the light rays are really coming from this point and just being bent in such a way that they diverge. Okay. That's the basic idea, at least for converging lenses. Okay, and so you get convergence if your object is farther away than the focal length, divergence in a virtual image if your object is closer than the focal length to the center of the lens.